Welcome to this presentation on the Henderson-Hasselbalcn equation. This equation will be very useful in connection with the buffer solutions. If we are asked to prepare a buffer solution of known pH, we have to use this equation. Now, a buffer solution, let us take, the H3O plus concentration is equal to Ka, that is the dissociation constant of the weak acid, into the concentration of acid divided by the concentration of the base. Now, if we write this equation in the log form, we know pH is equal to minus log H3O plus. So, we write minus log Ka minus log of acid to base concentrations. Now, we can define a term called pKa, which is equal to minus log Ka. Ka is the dissociation constant of the weak acid. Now, this is by analogy with pH is equal to minus log H3O plus. So, minus log of acid to base concentration will be equal to log of base to acid concentration. Now, the Henderson-Hasselbalcn equation is pH is equal to pKa plus log of base to acid concentration. Now, we know that for pH of a buffer solution, it has to have a value close to the pKa value, and it differs only by the amount of log of the base to acid concentration. Now, suppose I take the base concentration and the acid concentration to be the same. Say base is equal to 0.1 molar, then acid also is 0.1 molar. Then that ratio will be unity. So, base to acid concentration, whenever it is unity, the log of base to acid concentration will be 0, because the log of 1 will be 0. So, the equation reduces to pH is equal to pKa. Now, that is the reason why for preparing a buffer solution of known pH value, we have to choose a weak acid and the conjugate base in such a way that the weak acid has a pKa value which is very close to the pH value. Then, by adjusting the concentration of the base and the acid, we can achieve the correct value of pH for the buffer solution which is desired. Now, let us see how pH will affect the percent dissociation of a weak acid. We will take one example where the pH is equal to pKa plus 2. Now, the log of base to acid will be equal to pH minus pKa, which will be equal to 2. So, the base to acid concentration will be 10 to the power of 2, or which is equal to 100 divided by 1. So, we can say that this weak acid is 99% dissociated. Now, you can take any other value also for that log of base to acid, and correspondingly you will get different values for the dissociation of the weak acid. So, the Henderson-Hasselbalcn equation is very useful for you in connection with the preparation of a buffer of known pH values. Now, we have come to the end of this presentation on the Henderson-Hasselbalcn equation. Thank you.